So today we are going to discuss the two basic terms in physics. These are the first is prefix. Prefix are the quantities or are the group of words which we use which we used or which we observe on the basis of the a value in which we have 10 as 10 raised power, we can say, in which we have a power of 10, like the prefix are, I can say in easy words, which are used on the at the place of power of 10. Okay, at the place of power of 10, we can say. So the prefix we have are, we can say, subunits. We can say also the subunits of a physical quantity, like in physics, in prefix, 10s power 6 is known as 10s power 6 is known as mega. Okay, 10s power 3 is known as kilo. Okay, 10s power 3 means 10 into 10 into 10, so it is equal to 1000. So we know that 1 kg, 1 kilo is equal to 1000 gram. Okay, it has been proved that 10 plus 10 s power 3 is equal to kilo. And we have more prefixes in negative also. So you can say the 10 s power 1 is equal to Tassi. Okay, 10 s power 2 minus 2 is equal to milli. 10 s power 3 we have centi, decimilli, centi, decimilli, centi. Then we have also nano, which is, I think, 10 s power 6 is nano, and 10 s power 18 we have 18, positive 18 we have hexa, and 10 s power minus 18 we have atto. So these are the some prefixes which are being used at the place of these 10 s power values. So as like an example, the first example we are having that 0.00012. Okay, so let me add one more 0, 2, 3. Okay, so point we have here. So in the prefixes, when we are adding prefixes, we have to make sure that a point is after a digit. 0 is not a digit, so here we have the first digit, we have 1. So 1, 2, 3, 4, 5, 6. Okay, so here we will use point. It becomes 1.2 into 10 s power minus 6. Okay, for example, this we are taking in the meter. So we are saying we are writing here meter. Okay, now 10 s power minus 6, 10 s power minus 6 is equal to nano. So 1.2 nanometer. So this nano we have used, this is called, now this complete is called the prefix. Okay, when we use prefix, it is 10 s power values are converted into the group of words. Then we have a second term which is scientific notation. Scientific notation. So what is scientific notation? To write any points value of the point into a power of 10, means converting a decimal value into a power of 10. Okay, so we have example. So first let me write to convert decimal values into the power of 10. Okay, so uh, we have two rules in to convert into a scientific notation. If we are moving point from this side to this side. So the power we are gonna take on 10, so that power will be coming in the negative way. Okay, that power will be coming in a negative way. If the point we are moving from here to this side, then we will be taking a power in a positive. Okay, for example, here we have seen, we are taking the example like we have moving point from here to here, so we have taken the negative side. I should again take one more example. So the example is like 0.00000134. Okay, so when I'm converting it into a scientific notation, so I will convert 1 2 3. Okay, 1.34 into 10 s power minus 3. So this is now converted into a scientific notation, and if you convert it into a prefix, if you want to add at the place of minus 3, you will add 10 s power minus 3 is equal to milli. Okay, not milli, is equal to centi. Okay, 1.34 into 10 power minus 3 is equal to, at the place of minus 3 you can also use centi. And when we are taking positive, one more example, 1 3 2 0 0 0 0 0. Okay, if in the value, if there is no point in a value, so we have a rule that if and in any value there is no point, means the point is on the end, the point is placed on the end. So you will take point from here to here, 1 2 3 4 5 6 7. Okay, 1.32 in 1.32 10 is power 7. Okay, 1.32 into 10 is power 7. So this is the in the positive one, positive power, and here we have the negative power. So here we have negative power, and this one is a value in the positive power. I hope you have got something from this lecture. Now we are moving forward on the other topic. So now we are going to discuss the new topic, which is NLOG. NLOG stands for Newton Law of Universal Gravitation. Newton Law of Universal Gravitation. So now we are going to discuss about this topic. What is the Newton Law of Gravitation? What is the statement? So the statement of the Newton Law of Gravitation is every object in the universe attracting with each other, having a force between each other, mm, attracting with each other due to their masses, and the force is directly proportional to the m1 m2. m1 m2 means mass 1 mass 2. Let me make a diagram first. So this one is m1, this one is m2. Okay, and the distance between these both is r, and the force which is applied here, that is called the force of gravitational force. So the statement said that every object in the universe attract each other uh, due to the force of attraction, due to the gravitational force, and due to this Newton law of gravitation, we have two equations, that force is directly proportional to the m1 and m2. Force is directly proportional to the m1 m2, m1 m2. And why it is directly proportional? Because जब mass बढ़ेगा the force will be increased. जब force बढ़ेगा तो mass will be increased. Okay. जब mass कम होगा the force will be decreased. And the first equation we have this, and the second equation we have force is inversely proportional to the r square, which means force कम होगी तो डिस्टेंस बढ़ेगा, डिस्टेंस कम होगा अगर हम इस डिस्टेंस को यहाँ तक लेके आए. इफ़ वी शिफ्ट दिस डायग्राम ओवर हेयर, सो रेडियस छोटा होगा, डिस्टेंस छोटा होगा तो फोर्स बढ़ेगी, ग्रेविटेशनल फोर्स विल बी इंक्रीज्ड. इफ़ आई शुड प्लेस दिस m2 here, तो रेडियस बढ़ेगा एंड द फोर्स विल बी decreased. So that is why, that is the rule, that force is directly proportional to the m1 m2 and force is inversely proportional to the r square, which means force is directly proportional to the mass of the directly proportional to the mass of the magnitude and inversely proportional to the distance of the square distance of the square. Okay, inversely proportional to the distance of the square between two objects m1 m2. Okay, the final equation that we are going to make is when we compare these two equations, the third equation we are forming, f is directly proportional to the m1 m2 and inversely proportional to the r square. Okay, when we are cancelling this directly proportional sign, we are always gonna use the is equal to and the constant. Here at the place of this sign we are using is equal to and the constant, and here we will use a constant which is gravitational constant. So this is the final equation of Newton law of universal gravitation. Okay, F is equal to G m1 m2 upon r square. R square. The unit of, if we want to take out the what is the unit of gravitational constant, this is the gravitational, this we have the gravitational constant, and this is discovered by this gravitational constant is the value which is given to the gravitational constant is given by the Henry I think Cavendish, or I think नाम उनका Cavendish है. The name or the value is given by the Henry Cavendish. Okay, and the value is G is equal to 6.67 into 10⁻⁻11 Newton meter square per kilogram square. So how this unit come? Okay, now we are gonna form this unit. This is a unit of gravitational constant. So we know that we have a formula of Newton law of gravitation. G F is equal to G m1 m2 upon r square. Okay, so here if you want to find the unit of G, we want to find the value of G. So G is equal to, here we have r is being divided with this value. When it will go on that side, this will be multiplied with this will become to multiply with force, and here it is dividing with r. Means here it is being multiplied with gravitation, and when it will be going on the other side, it will divide, it will be coming m1 m2. So here we know that G is equal to Fr square upon m1 m2. The unit of force is, we have Newton, and the unit of r, distance, is meter, and square same, and m1 and m2, mass 1, mass 2. So the Newton becomes Newton meter square per kilogram square. Okay, Newton meter square per kilogram square. This is the unit of gravitational constant. And now what is the dimension of this Newton meter square per kilogram square? So let's find the dimension. Let's come forward. So dimension. So here we are going to discuss about how to find dimension. So from the unit we have Newton meter square per kilogram square. So Newton the dimension for Newton is ml t minus 2. This is the dimension of Newton. Okay, ml t minus 2. This is the dimension of Newton. Okay, so and now we will find the dimension of this complete. So at the place of Newton we will write m l t minus 2. M square means meter square. So at the place of meter square you will write L means length. So because the unit of the meter is a unit of length, so length square L square L2 upon kg square. So kg is a unit of mass. So m is 2 when it will go upstairs up when it will be going from denominator to the numerator. Then we have the we'll place a negative sign. So the dimension for this we have there is a mistake. So let me find it again. Newton is as we know that the dimension for Newton we have ml t minus 2. So m l t minus 2 meter square will place L square upon the place of kilogram we will write m square. Okay, so this m will be cancelled with this one m. Okay, now we have L t minus 2 L2 upon m. Okay, L2 upon m. Then we have m minus 1. We will go here, it will be minus L 2, and when we have no power it means there the power 1. 2 plus 1 L cube and t minus 2. So this is the dimension of the Newton gravitational constant. This is the dimension of gravitational constant. Okay, and this gravitational constant is the value of gravitational constant is given by the Henry Cambridge, and scientist named as Toyer balance. It tells about the equipment by which we can measure the gravitational constant. He tells us about the equipment to measure gravitational constant. Okay, it tells us about the equipment to measure the gravitational constant. So one more thing we have to do for discussing here is that here we have two objects, m1 m2, and here we have r, and the force between m1 and m2 is called the gravitational force. So we know that the force which is applied from m1 to m2, जो force m1 से m2 will be applied, जो force लगेगी m1 से m2, the force which will be from m1 to m2, the same magnitude of force will be coming from m2 to m1, which means F here, let me write it here. Okay, here we have the two objects, the force from m1 to m2 and the force from coming from m1 to m2 to m1. Okay, force from one object to two second object F12 is equal to the force coming from second object to the first object. So F12 is equal to F21. Here we will add a sign of minus. Okay, here we will add a minus sign of minus. Why we have added the minus sign? The negative sign is coming because of we can say the opposite direction of the forces. Here force is going from m1 to m2, and here the force is applied from m2 to m1. Because of these negative charges, we are adding a minus, and the force which is applied from m1 to m2 and m2 to m1 is equal. The magnitude of the force is equal. जितनी force m1 से m2 जाएगी, उतनी ही force m2 से m1 ही आएगी. So that is why force is directly proportional to the m1 m2, and F12 is equal to minus F21. Okay, and the net force is always 0. We know that in every law, in Coulomb's law and in others law, the net force is always 0. Okay, and this Newton's law of gravitational is mostly significance on heavier bodies. Okay, significance on heavier bodies. These are some major points which I am telling you for the MCQs. And so this is the point which is know that uh, Newton law of gravitation is majorly applied on or significant on the heavier bodies. Hope you have enjoyed this lecture. Bye bye. See you in the next video.